To appreciate why we need session management, we first have to understand the web's foundational protocol, HTTP. By its very nature, HTTP is stateless. What does that mean? It means every single request you send to a web server is treated as a brand new, isolated event. The server has no built-in memory of who you are or what you did just a moment ago. This poses a significant challenge for creating interactive applications. Imagine talking to a cashier who has zero short-term memory. You ask for a coffee. They serve it. Then you ask for a donut, and they respond, "Who are you? Haven't met before?" That's exactly how a web server operates over stateless HTTP. Without session management, it would forget you after every click, making it impossible to log in, shop online, or have any personalized experience. Now, let's see how we give this forgetful server a memory. So, how do we solve this? We create a session. A session is essentially a temporary and private conversation established between a user and the web server. It's a conceptual wrapper that groups all of your individual stateless HTTP requests into a single continuous interaction. The entire goal of session management is to create and maintain this conversation, making the web feel stateful and responsive to you as an individual. For this conversation to work, the server needs a way to recognize you each time you make a request. It does this by creating a unique identifier called a session ID the moment your session begins. Think of it as a unique digital name tag or a keycard assigned only to you for the duration of your visit. This ID is the crucial piece of information that links your browser to your specific data on the server. Now, it's vital to understand the separation between the session ID and the actual session data. While the session ID is a simple identifier that travels back and forth, the valuable information, like your user ID, your shopping cart contents, or your language preferences, is stored securely on the server. The session ID is just the key. The server's storage is the locked room containing all your personalized data. So we have this unique session ID, but how does it actually travel from the server to your browser and back again with every request? The most common method by far is using HTTP cookies. A cookie is a small piece of data that a server sends to a user's browser. The browser stores it and sends it back automatically with every subsequent request to that same server. This makes cookies the perfect vehicle for carrying the session ID. Let's walk through the entire flow from the beginning. First, you visit a site or log in. The server receives your request, determines you need a session, and generates a new, unique session ID. The server then sends this ID back to your browser, typically inside a cookie. From that moment on, your browser automatically includes that cookie with the session ID in every follow-up request, allowing the server to recognize you every single time. But sessions don't last forever. For security and resource management, they must end. This is handled by session expiration. Typically, a session can expire in two ways: through an absolute timeout, where it expires after a fixed duration like 30 minutes, or through an inactivity timeout, where it expires if you haven't made any requests for a certain period. Once expired, the session ID becomes invalid. In addition to automatic expiration, you can actively end your session by logging out. When you click the Log Out button, your browser sends a request to the server, which then performs session invalidation. This process immediately destroys your session data on the server and makes your session ID invalid. This is a critical security feature, especially on shared computers, as it ensures no one can use your browser to access your account after you've left. Now we arrive at the most critical part of our discussion: security. Because the session ID is the key to your account, it's a prime target for attackers. The most common attack is session hijacking, where an attacker steals a user's valid session ID. If they succeed, they can use that ID to make requests to the server, effectively impersonating the user and gaining full access to their account. So, how do we defend against this? Our first and most fundamental line of defense is HTTPS. By encrypting all communication between your browser and the server, HTTPS creates a secure, private tunnel. Even if an attacker is monitoring the network, they can't read the traffic. Your session ID, along with all other data, is scrambled and unreadable, effectively neutralizing any attempts to sniff it out and steal it in transit. Next, we secure the cookie itself. We can set two special flags on our session cookie for enhanced protection. The secure flag tells the browser to only send the cookie over an encrypted HTTPS connection. The HTTP-only flag prevents the cookie from being accessed by client-side scripts, like JavaScript. This is a powerful defense against cross-site scripting, or XSS attacks, where an attacker injects malicious script to steal the cookie. Another powerful technique is to regenerate the session ID at key moments, particularly right after a user logs in. This defends against session fixation attacks, where an attacker tricks a user into using a session ID that the attacker already knows. By generating a brand new ID upon successful authentication, the old pre-login ID becomes useless, ensuring the user's new authenticated session is completely fresh and private. While cookies are the standard, modern web development has seen the rise of token-based authentication, often using JSON Web Tokens, or JWTs. Unlike traditional sessions where the server stores all the data, a JWT is a self-contained token that holds user information directly. The client stores this token and sends it with requests. This approach can be more scalable for certain architectures, but it comes with its own set of trade-offs and security considerations. As applications grow, they often need multiple servers to handle traffic, which introduces a new challenge. If your first request goes to server A, but your next goes to server B, how does server B know about your session? The solution is a centralized session store. This is a shared database or cache, like Redis, that all servers can access. This way, no matter which server handles your request, it can look up your session ID in the central store and retrieve your data. To summarize, building secure and robust session management is non-negotiable for modern web applications. Let's review the best practices. Always enforce HTTPS. Use long, random, and unpredictable session IDs. Set the secure and HTTP-only flags on your cookies. Regenerate the session ID after login. And always invalidate the session completely on logout. Following these rules will create a foundation of security and trust for your users. From understanding the web's forgetful nature to implementing the layers of security that protect our digital conversations, you now have a comprehensive overview of session management. It's the silent hero that makes the modern, interactive web possible, ensuring every user has a seamless, personal, and secure experience. Thank you for watching, and happy coding!